Good afternoon, AP Stats students. This is Mr. Hazelhorst coming to you live from room A08. I'm going to leave you a little introduction video today here on Chapter 4. And what we're going to get into in Chapter 4 is designing studies. We're going to look at all kinds of different studies. We'll look at both observational and experimental studies. But today we're going to kind of begin with some basics that will hold true through a lot of what we talk about in Chapter 4. So there's going to be a lot of terms kind of coming your way and some important concepts. And so as we work through this video, I'd encourage you to take those notes, that note sheet that was handed out, and jot down, highlight, add to anything that you need to here through Chapter 4. All right, let's get it rolling. Well, first off, the big thought that we need to understand as we get into this idea of designing studies is the idea of sampling. And it's really important to understand up front that the goal of sampling is to collect a manageable group of people or items that represent a given population without bias. And there's a lot in that definition that you're going to see us talk about today. We're going to talk about this idea of sampling, right? We're going to talk about this idea of a manageable group. We're going to talk about the idea of population. We're going to talk about the idea of bias, okay? Now, one thing that's really important to understand is that there would really be no purpose or reason to have statistics if we could just simply work with a population all of the time. If we could just deal with a population all the time, that would make our lives really easy, all right? But the reality is we can't, all right? We recognize that in most cases, a population is really hard to manage because it involves so many people. And so to collect the data about all those people or all those things, whatever it might be, is extremely difficult and would take a lot of time. And in the business world, if it takes a lot of time, it takes a lot of money, all right? So that's where the whole idea of statistics was really born from, right? So a couple of terms, all right? Population, first off. This is the entire group of individuals that we want information about. And if we could deal with every single person or item in a population, well, we call that a census. All right, and that's not statistics. All right, statistics technically don't apply in a census setting. Anything that we collect through a census are really facts. They're truths about that population. But the reality is it's very hard for us to deal with an entire population. So what we do instead is we work with a sample. We work with a subset of the population that we collect data from. And this is the idea of sampling, right? Studying a part in order to gain information about the whole. And that's really what statistics is all about. Can I look at a smaller set of data and draw some conclusions or some inferences from that sample of data that I can then again draw conclusions or inferences about the population as a whole? And that's what we're ultimately trying to do in statistics, all right? So a couple of example problems here real quick, and it's really important that we have the ability in any given situation to recognize what's the population that we're trying to study and what's the sample that we're using to study that given population. So here's a couple of example problems for you, all right? So within each of these, I'm going to ask you to identify the population and the sample, all right? So we'll do the first one here. It says a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. Wood that isn't dry won't hold its shape and size. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. Okay? If any piece exceeds 12% moisture content, then the entire batch is sent back. All right? So within this problem, we want to identify the population and the sample. Okay? And the sample is usually really easy to identify, right? The sample in this problem is those 5 pieces of wood. Right? That would be our sample. Right? It's not the entire shipment of wood. It's just a few pieces selected from that shipment. And then our population in this problem is not all wood that could be possibly used, but it's just simply the batch that we're working from. All right? So this entire batch would be our population. So we're not studying every single piece of wood, all right, within the population. That would take this person a lot of time, and this person's job isn't to test the moisture content of wood, it's to build furniture, okay? So the population, again, is that entire batch, and the sample would be the pieces of wood, okay? So you do this one now, the next one that's on your note sheet. All right, each week, the Gallup poll questions a sample of about 1,500 adult U.S. residents to determine national opinion on a variety of issues. Okay? So take a moment there. I want you to circle or underline the sample, and then circle or underline the population. All right, so let's see what you came up with, okay? So in this problem, if we were being specific, right, the sample would be the 1,500 U.S. residents. And the population would be all U.S. residents. Okay. So again, we want to be able to identify the sample and the population from within a given setting. All right, well, the next concept that we want to hit on, we've talked a little bit about sample and populations. Now we want to get into some specific sampling techniques. And I want to start off with the bad. What are bad ways that we could collect data for us to use in a statistical setting? All right? And when we talk about the bad, what it boils down to is the word bias. Okay? And this is something that we want to avoid. If we go back to our big thought of the day, if you look back towards one of those first slides, we said we want to represent a given population without bias. And so bias from a statistical standpoint is when we systematically favor some outcome over others in our sampling method. All right, and oftentimes bias becomes apparent when a statistical study either consistently underestimates or overestimates the value that we're trying to find. And the reason why it always underestimates or overestimates is because it's a biased study. And so as we think through things from a statistical standpoint, we always want to think about what could be possible bias that's included in the design of this study, all right? Because if we use that phrase systematically favors, that means that it's favoring something because of how we designed a study, all right? And that's really important for us to recognize and understand. And so as we go through the next couple of examples, I want you to be thinking about how does the design of the study lead to bias? All right. So let's give you a couple of examples of bad ways to collect data. So the first method that as students of statistics we really want to avoid is what's known as a convenience sample. Right? And a convenience sample is when we choose individuals from a population that are just easy to reach. Right? That's where it gets its name from, convenient. It's easy for us as the data collectors to collect this data. Okay? An example of this would be if you just stood outside the hallway of my classroom and asked the first 10 students that walked by, you know, where they work at or how many hours of work they week or how many hours a week they work, that would be an example of the convenience sample. Okay. Now the example that I have on the slide board or on the board right now is we have the parent of a football player is concerned about proposed budget cuts to the athletic program at the school. So she asks spectators at a game if they agree with the proposed cuts. All right, so she is collecting data. All right, she hasn't collected the data of all parents involved in the school program, right? She's just selected a sample of them. But think about the bias that would be present if this is her data collection method. It should be very obvious to us, right? Like all of these people have bias towards the support of the athletic program, right? They are people at an athletic event. More than likely, they are football fans. And so this type of data collection method would systematically favor people who would be against budget cuts, okay? And that's what we need to recognize. So if she were to take this data to the school board in support of her argument, right? Well, it's really not valid data because, again, the design of the study or the design of the data collection method is biased in terms of how it collects that data. It's biased towards support of the football team and athletic department as a whole. I'm not saying that's a bad thing, but from a statistical standpoint, this is not correct. Okay? The other type of method that we want to avoid is what's known as voluntary response samples. All right, and this is where we collect our data in a way that people have to choose for themselves to respond or be a part of our study by taking us up on some sort of invitation. Okay, phone surveys and online polls or polls where you text in, those are generally voluntary response, right? We are asking people to call in or to go online and fill something out or to text into a number. Okay? And so here's the example that we give. The ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. And there was a charge for calling. More than 186,000 callers responded, and 67% said no, meaning they did not want the headquarters of the UN in the U.S. anymore. Okay? Now, again, why is this bad? Well, this design of data collection has bias involved, right? Think about the people who are going to call in and spend their own money in this sort of a setting. Right? Usually the only people who partake in a voluntary response sample are those people who are very passionate about a given topic or study or are highly opinionated about, again, a topic or a study. Right? If you were to be watching that TV show Nightline, how many of you would have spent your own money to call in? My guess is very, very few of you. And for those of you who are, it's probably because you have a really strong opinion one way or the other. Okay, so in a voluntary response sample, we're not collecting good data because we're just inviting those people who are most passionate or the most strongly opinionated really to partake, because those are the people who generally will. Okay, if I don't care that much about something, I'm not going to take the time to call in, or I'm not going to take the time to go online and fill out a survey. But I am a part of that population and need to be included in that as well. All right, so we can see some obvious bias just by the design of the data collection process. So if those are bad, we then have to ask the question, well, what's good? Okay, and the good comes down to what we call in statistics random sampling. Right, we should use a chance process to determine who's included in our sample. Right now, when you use the phrase random in just your day-to-day lingo, a lot of times we think of that as just kind of being haphazard. You know, like if you say that was so random, right? It's just out of the blue, out of nowhere. And that's not what we mean in statistics. Right? When we use the word random, all we mean is that it's due to chance. Okay, chance meaning everybody has the same chance of being selected. Everything has the same chance of being selected, but probability is what's doing the selection for us ultimately. All right, and there are three types of random sampling that from a statistical standpoint are proper and wise to use. The first is what's known as a simple random sample, and oftentimes you're going to see this abbreviated in your textbook as SRS. So if you see SRS in your textbook, that's referring to a simple random sample. We also will talk about a stratified random sample and a cluster sample. All right, so we want to talk about each of these three here to finish out the video. All right, so let's start out with a simple random sample. Okay, and the whole idea behind a simple random sample is just simply that every group of individuals in a population has an equal chance of being selected as whatever sample we do select. All right, so there's no bias involved. Everything has a fair chance at being a part of our data. All right, and the most simple type of random sample simple random sample is just drawing names out of a hat, right? I mean, you guys have been involved in all kinds of different simple random samples, I'm sure, over the course of your educational careers, right? Teachers pull names out of a hat. Who's going next, right? Everybody in the hat has an equal chance of being selected. There's no bias involved. You're just pulling names out, okay? And this whole idea of the hat method really holds true even in a larger setting. in statistics. And there's going to be two different ways that I will expect you to be able to complete an SRS. All right, now I'm going to encourage you to look in your textbook when this video is over on pages 215 and 216, or on the digital copy of your book, page 243 and 244. And I want you to look through it, how you can use technology and how you can use what's called a random digits table to collect your sample. All right, now on your homework assignment today, you're going to get some practice doing each of those things. And I know that you people are intelligent enough to look through your textbook on each of those 2 pages and figure out how to do this. It's a very simple thing, but it's a process that I will expect you to be able to do. So again, take the time to look through your textbook and figure out how to find an SRS using your calculator, that's technology, or the random digits table, okay? And you'll get some practice with this later on this chapter as well. But again, I expect you to figure that out. All right, so that's an SRS. The other 2 types of sampling are what we call a stratified random sample, would be our second one. All right, and this is where we start out by taking a population and we divide it into groups of similar individuals. All right, and then we're going to choose an SRS within each of these groups and combine those to make our simple random sample. Okay, and so the best example I can give you of a stratified random sample would be to think of a high school. Let's say that we wanted to collect data about the number of hours a week the typical high school student at Papillion La Vista South studies. Okay, now when we think about that, we recognize right off the bat, well, there's big differences between a lot of things, right? Particularly in the grade levels, right? A freshman doesn't necessarily study the same amount as a junior or a senior, right? So we would go, okay, let's make sure we include all of these important subgroups, right? We want to make sure that our study contains freshmen and sophomores and juniors and seniors, all right? And so what we'll simply do is, okay, well, let's take the population and let's divide it out amongst those grade levels. And the grade levels would be our strata in this example. And they're all important to be included. Now, I know you might make the argument that nobody cares about freshmen, but the reality is, in this example, they would be an important part of the population. So we need to include them. All right, so we would have our freshmen in one group, our sophomores in one group, our juniors in one group, and our seniors in one group. And we would just simply select maybe 25 individuals at random, right, using an SRS from within each of those 4 strata. And then we would combine those together to make our group as a whole. All right, and the benefit of that is that we guarantee that every important subgroup is represented within our sample. Right, we help eliminate any potential bias by only creating all seniors or only selecting all freshmen or something along those lines. Okay, so a very simple sampling method, and we're going to go through an activity in class here tomorrow to help you see this type of sampling method. All right, the next type is what we call a cluster sample. And this is where we start by, again, dividing the population into groups, but this time those groups are just simply created based on location. All right, they're not composed of similar individuals, but again, just location. And then we choose a simple random sample of the clusters. And then all the individuals of each of those clusters are a part of our sample. All right, and the best example I can give of a cluster sample is, let's go back again to studying students at Papillion La Vista South High School. And so maybe what we do is we just say, okay, you know what we're going to do is during 4th period tomorrow, we're just going to randomly select 10 classrooms. All right, and those 10 classrooms are then going to make up our simple random sample. And we'll ask those students, how many hours a week do you study? And there will be our data. All right, and the reason why that's a cluster sample is, those students are put in those classrooms. They're just all near each other, right? So we walk in, we can say, okay, we've got Mr. H's classroom and Mr. Marsh's classroom and Coach Cooley's classroom, right? And those students are already there, and there's a very good chance that there's a mix of a lot of different students within those classes, okay? Now, some people would compare a cluster sample to a convenience sample, but it's really important to recognize that they are not the same thing. Right? We're not conveniently standing in one location. Right? We're still giving every group the same opportunity of being selected. Right? There's still randomness that's selecting the clusters. Okay, so we still have that random sample involved. And the benefit of a cluster sample, if it just makes us more efficient, okay, it's really what it boils down to. And that's a benefit to us in statistics, all right? So we've kind of covered a lot today, lots of different terms, but you've got those all in your note sheets. And I hope as we went through that kind of helped clarify some things. I'm going to highly recommend that you complete this homework assignment. There's a lot of concepts in this video that are important to make sure that you understand. All right, so take the time to complete this homework assignment and enjoy the great cartoon on the sideboard. So I hope you guys have a great day, and I will see you on Friday.